So here in this question, we need to determine the limiting value of the given function when x approaches infinity. So when we substitute for the value of x, what we are getting here is square root of infinity squared, which is infinity, plus c times infinity, which will be infinity. So infinity added to infinity is just infinity minus infinity, and taking the square root is giving us infinity as well. So this is having the form of infinity minus infinity. It is an indeterminate form. So what we have to do, the given function f of x must be converted into the form gx over h of x. So it should be converted to a quotient form. So that can be done by taking the function which is x squared plus c of x, cx minus x, and what we're going to do, we're going to multiply and divide it by its conjugate. So its conjugate will be x squared plus cx plus x divided by the same conjugate, which is x squared plus cx plus x. Now the reason why we have done this, that is because now when we look at the numerator, now this is a product of an identity. Now this is giving us an identity which is having the form a minus b multiplied to a plus b. So that can be transformed into a squared minus b squared. So we have limit x approaching infinity. So we have square root of x squared plus cx whole squared minus x squared in the numerator divided by x squared plus cx plus x in the denominator. So which will be limit x going to infinity. So the square of a square root, we'll get rid of the square root. So we'll have x squared plus cx minus x squared in the numerator divided by x squared. So let's do one thing. Let's take x squared as the common factor in the denominator. So that will leave us with 1 plus c over x. The reason why I've done this will become evident in a moment. So plus x. Now we have limit x approaching infinity. So x squared and negative x squared gets cancelled out, leaving us with cx divided by the square root of x squared. So square root of x squared is simply x, so we can take it out of the square root. That leaves us with 1 plus c over x plus x. Now the reason why I took x squared as the common factor inside the square root is because I wanted to take x as the common factor from the two terms in the denominator, so that we have square root of 1 plus cx plus 1. Now this helps us in cancelling out x from both the numerator and the denominator. Now we have c in the numerator divided by 1 plus square root of 1 plus c over x in the denominator. This is where we have to calculate the limit. So limit x goes to infinity. Now when we substitute for the value of x, we have c over 1 plus square root of 1 plus c over infinity is going to be 0. So that leaves us with c over 1 plus square root of 1 is 1. So we have c over 2. So this is going to be the limiting value of the given function when x approaches infinity. So here we have to determine the limiting value of the given function when x approaches an extremely large number. Clearly, when we substitute for the value of x, we are getting an infinity minus infinity form. However, what we have to do for the given function f of x, we have to convert it into a rational form. So we have gx over h of x. So in order to do that, we have to multiply both numerator and the denominator by the conjugate of the given function. So that will be limit x approaching infinity square root of x plus 1 minus square root of x So the conjugate of this particular function will be square root of x plus 1 plus the square root of x. So we have to multiply to the denominator as well. So we have square root of x plus 1 plus square root of x in the denominator. Now, when we multiply the two terms in the numerator, that will be simply equals to square root of x plus 1 squared minus square root of x whole squared. That's because it's having the form of a minus b times a plus b, which transforms to a squared minus b squared, divided by the square root of x plus 1 plus the square root of x. Now we can get rid of the square roots in the numerator, so that will leave us with x plus 1 minus x divided by square root of x plus 1 plus the square root of x. So the x and x gets cancelled out, and we are left with limit x approaching infinity. We have 1 in the numerator divided by square root of x plus 1 plus square root of x. Now there is nothing to cancel out from the numerator and the denominator, so we'll substitute for the value of x. So that leaves us with square root of infinity plus 1 is going to be infinity, and taking its square root is going to give us infinity. Similarly, square root of infinity is again infinity, and adding to another infinity leaves us with infinity only. So this is giving us a value of 0. So that means the given function approaches 0 when x approaches infinity. So here we have to find the limiting value of the given function when x approaches infinity. Now this particular question is very much similar to the previous question. So in the previous question we had limit x approaching infinity square root of x squared plus cx minus x, and that gave us the value of c over 2. So when you compare it to the previous question, we have c is equals to 7. So that means the limiting value of this given function is going to be 7 over 2. So we have to determine the limiting value of the given function when x approaches infinity. So when we substitute for the value of x, we are going to get the form infinity over infinity. So this is an indeterminate form. So what we're going to do, we are going to rewrite our function. So we have x going to infinity. Now we see that the highest power of x in both the numerator and the denominator is 1. So we have x raised to the power of 1. Similarly, in the denominator we have x squared. Taking the square root gives the highest power of x as 1. So we're going to factor out x in the denominator. So we have x divided by, so when we factor out x from the square root, so we have x multiplied to 4 plus 1 over x squared minus 1. Now we are going to factor out x from both the two terms of the denominator. So that leaves us with x over x multiplied to square root of 4 plus 1 over x squared minus 1 over x. So we cancel out x from both the numerator and the denominator, and that leaves us with limit x going to infinity 1 over square root of 4 plus 1 over x squared minus 1 over x. Now when we substitute the value of x into a given function, so that will give us 1 over square root of 4 plus 1 over infinity square is going to be 0 minus 1 over infinity, which is also going to be 0. So that gives us 1 over square root of 4. So square root of 4 is 2, so that our final limiting value is half. So this is the value that our function assumes when x approaches infinity. So here in this particular question, we have to determine the limiting value of the given function when x approaches infinity. So this is 3 over x 3 over x. So when you substitute the value of x, so we have 3 over infinity plus 4 over infinity squared, which is infinity, divided by 5 over infinity plus 6 over infinity. So we have 3 divided by an extremely large number is going to give us approximately 0. So we have 0 plus 0 divided by 0 plus 0. So this is an indeterminate form. Now what we're going to do, we're going to factor out the highest term of x from both the numerator and the denominator. So the highest power of x is -1 here. So we divide both numerator and the denominator by the highest power of x. So that will leave us with 3 plus 4 x times x raised to the power of -1 divided by 5 plus 6 x raised to the power of -1. Now when we substitute for the value of x, so we have 3 plus 4 divided by infinity plus 5 divided by 5 plus 6 divided by infinity. That leaves us with 3 plus 0 divided by 5 plus 0. So we have a limiting value of 3 over 5. So in this particular question, we have to find the limiting value of the given function when x approaches infinity. Clearly, when we substitute for the value of x, we are getting an indeterminate form of infinity over infinity. So that means we have to rationalize the numerator as well as the denominator. So let us begin by rationalizing each of it. So we have limit x going to infinity. So we take the numerator, which is x squared plus a squared minus x squared plus b squared. So the conjugate of this function is going to be square root of x squared plus a squared plus square root of x squared plus b squared. Now we have to multiply to the denominator as well. So we have x squared plus a squared plus x squared plus b squared. Then we come to the denominator part. So we have in the denominator x squared plus c squared minus square root of x squared plus d squared. Now the conjugate of this particular function is going to be square root of x squared plus c squared plus square root of x squared plus d squared. So we have to multiply it to the denominator as well. So we have x squared plus c squared plus the square root of x squared plus d squared. Now we are going to combine this particular function with this one because they are of the form a minus b times a plus b. So that will transform into a squared minus b squared. Similarly, we'll consider this particular function and multiply it to this particular function, which is its conjugate, and convert it into a squared minus b squared form. So let us do that. So we have limit x going to infinity. So square root of x squared plus a squared whole squared is simply going to give us x squared plus a squared minus the square of square root of x squared plus b squared is going to give us x squared minus b squared times the remaining part, which is square root of x squared plus a squared plus the square root of x squared plus b squared divided by, we have x squared plus c squared minus x squared, this is plus b squared plus d squared times square root of x squared plus oh, there's a mistake here. So here we have c squared and d squared. So we have x squared plus c squared plus square root of x squared plus d squared divided by x squared plus a squared plus the square root of x squared plus b squared. Yep, there's a small mistake that I made. Now, coming back, we have limit x approaching infinity. So here the x squared term will get cancelled out. So x squared and negative x squared will cancel out, and that will leave us with a squared minus b squared times the remaining function. Now what we're going to do in the function here, we are going to pull out x from inside the square root. So that will leave us with x times the square root of 1 plus c squared over x squared. Plus similarly, we're going to pull out x from inside the square root. So that will leave us with 1 plus d squared over c squared divided by, so we have positive x squared cancelling negative x squared, leaving us with c squared minus d squared times x, taking x as the common factor. So we have square root of 1 plus a squared over c squared plus x times the square root of 1 plus b squared over x. This is x squared, b squared over x squared. Now a squared minus b squared over c squared minus d squared will be treated as a constant because it does not have an x term, so we can take it out of the limit. So we have limit x going to infinity. Now we can divide each of the term in the numerator by x, and similarly each of the term in the denominator by x. So that is going to leave us with square root of 1 plus c squared over x squared plus square root of 1 plus d squared over x squared, whole thing divided by the square root of 1 plus a squared over x squared plus the square root of 1 plus b squared over x squared. Now we're going to substitute the value of x. So we have a squared minus b squared divided by c squared minus d squared. So we have square root of 1 plus c squared over infinity squared will give us 0. So we have 1 plus 0. Similarly, here we have 1 plus 0 divided by square root of 1 plus 0 plus the square root of 1 plus 0. The square root of 1 will be simply 1, so that means in the numerator we have 2, and so in the denominator we have 2 as well. So that will get cancelled out, leaving us with a squared minus b squared over c squared minus d squared. So this is going to be the limiting value.